Vô đi.
Hello, teacher. On behalf of Group 8, and I want to show you the topic that assembly language. And next is the member in my group. The first is Trương Tấn Tài, the second is Nguyễn Minh Nhật, the third is me, and the last is Nguyễn Hữu Châu Hoàng. And in the first question about the assembly language report, adding to integer in memory, I want to show you about the assembly language. It's a low-level programming language that communicates directly with the computer's hardware as you mnemonic codes and label to represent machine-level instructions, offering precise control of system results. Assembly programs are tailored specific processors. Actuators are essential for performance critical or hardware manipulating allocations, and in this report present a simple assembly program that adds to integer stored in separate memory locations and save the result in the third location. The exercise lays the foundations for understanding memory models, register operations, and instruction executions. And next to the next question is objective of there's assembly addition program. In the first is the memory operations. We introduce memory operation using assembly language instructions. And next instruction use. This demonstrate low move add and store MOV instructions. And the third is program writing. The write and explain the symbol program performing integer additions. And the last is the accuter comparisons. It compare basic operation across generic assembly and its 86 accuters. And the last part I want to show to the teacher and everyone is the K assembly language concept. That the first one is the registers that have a small fast store area in the CPU used for operations. And the next is the memory addressings that are methods to access specific memory locations. And the third is instruction set that predefined operations like the ADT and MOV available to the CPU, and the last is symbol that is tool translating assembly code into the machine code and is executable by the CPU. Thank you, teacher, and everyone to hear me.
Hello, teacher and everyone. This is my part. It's about the basic assembly instruction use. It had three parts. I will introduce you about the assembly. It load value from memory into the register like accumulator. The second is like the name. It add the value of a register on a memory location to a register, and the last is the store. It store the value from the register back into the memory location, and it's about the program design and the memory location. The memory location had three parts. A is first integer, P is second integer, and C is resource after addition. About the operation sequence, the CPU follow a fetch execute model logged in data, processing it, then store the result sequentially. Next slide, please. Let's see a sample code. A sample code is the generous assembly. You can see the lot A. It load a value from A into accumulator. At B, it add value from B to accumulator. Store C is store resource in the C, and the heart is a end program. Uh, data 5 is the first integer, B data 7 is second integer, and C data 0 is resource storage. And this is the end of my part. Thank you.
Hello, my name is Nhật. With uh, representation about explanation of the sample code. Let's work through the sample assembly like code line by line to understand each function step by step. The first is load 8. This instruction feed the content from the content from memory location and place it into the accumulator. This prepare the first operand for the feature operation. The second is add B. Here we take a value stored in the memory location B and add it to the accumulator with the already holds the value from 8. After this step, the accumulator contains the result of 8 plus B. The third is store C. Now that we have a result of 8 plus B in the accumulator, this instruction stores that result into the memory location C. The last is finally the hard instructions of the program execution, indicating that all intended operations are complete. And now we move to the sample output and the vertical occasion. In this final step, we have verified whether the program has executed correctly the stemming the output. The integer values we start with two integer values. A is set to 5 and B is set to 7. The result after running the program, the value stored in the memory location C is either 12. The confirm that the addition operation A plus B were successfully carried out and that the results were correctly stored. Therefore, the output that our sample code work on static and the logic of loading, adding, and storing data is properly implemented. And that is finished my presentation. Now we move to the time.
Hello everyone, my name is Tai. I will present the final part in this article. Comparative version is a-digit absolute. MOV AX A move content of A into register AX. Ask AX B add content of B to AX. MOV C AX store result from AX into C. x86 use general purpose register like AX, base, C, system reference logical flow remain the same as generic assembly. Next is application and calculation. Number one, real world use embedded system programming, reverse engineering, debuggery, and system optimization. Second, contribution, and then understanding assembly, automated operation build a foundation for complex system-level programming and exchange, debugging, and optimization skill. Knowledge of assembly. Language bridge the gap between high-level cost and hardware. Empowers developer to wide efficient low-level software. And this is the presentation of my group about the assembly language. Thanks for your listening.